In this problem, we are to identify the domain, the range, and the horizontal intercepts of several quadratic functions. You'll find that the video is going to be long enough if I just pick one. So I picked the first one, and I'm going to explain what the domain is in interval notation. I could easily just give you the answers. All the answers to all the quadratics are the same. It turns out when you graph a parabola, in this case my a value is positive, it'll be like a U-shaped curve, and the graph looks like it's trapped in a finite region as far as how left and how far right it goes. So I actually have some students that don't believe me when I say the domain is all real numbers. I try to argue that the graph goes to the left forever and to the right forever, but it doesn't look that way, especially in the graphing calculator. It kind of looks like, because the graph goes so steep, that the graph is trapped between, say, these two vertical lines. So to give a counter argument to the thinking, I offer them this. Suppose that the graph was trapped by some number, say 10 or something. I ask them, do you seriously think that if I was to plug in x equals 15 into the equation here, that I'm not going to get a y value out? I mean, you can square 15, take the answer, multiply by 3. You're not going to have any issues multiplying 15 by 12 and adding 2. So usually when you restrict your domain, it's because you're doing something like dividing by 0 or trying to take the square root or any even root of a negative number. That's not the case here. So it turns out that when you plug 15 in, you'll get a y value, and you can plug in any x value and expect to get a real number y value out of it. So it turns out the domain is all real numbers, but the hitch is they said to write the domain in interval notation. In the interval notation, they want you to write the lowest x value, comma, biggest x value that you're allowed to plug in. In our case, the smallest x value you can plug in would be, negative infinity as far as it goes. So as far as, say, a real number line is concerned, if you were to graph all the possible x values that work, it's everything. It's all real numbers. So it goes, you're allowed to plug in x values as far as, say, negative infinity, we call this, or as big as you want in the positive direction, and we call that positive infinity. So the domain interval notation is going to be the smallest x value you can put in would be negative infinity, which you never actually reach it, so you use a parenthesis as opposed to a bracket. And then the farthest to the right the graph goes is forever to the right, so that would be infinity. And you never reach infinity, so I'm going to put a parenthesis there to indicate that you can't actually plug in infinity in there. Infinity is not a real number. So at any rate, this is what you type in there for all of them. Left parenthesis, negative infinity. You can get an infinity by doing double O's. And then comma, positive infinity. So again, two lowercase o's, no spaces. And just to show you, when you hit preview, it converts it into that notation. The other way you could have done it was to use this math quill feature if your teacher has that on, and it has the symbol infinity there, and that would work just as well. Now on to the next problem. So by the way, you could actually copy and paste that into all of these, because all quadratic functions have its domain as negative infinity to infinity. The range, there really is sort of two cases with the range, depending on whether your parabola opens up or down. The range is what are the y values you could possibly get out. You're allowed to plug anything in, but you're not going to get out all possible y values. There's going to be a limit to what you get out. And usually that easiest way to ascertain that is to graph it and see how low or how high the graph goes. So in a minute, I'm going to have to graph this function anyway to find the horizontal intercepts. So I might take the time right now to grab my calculator, turn it on, press y equals, type in the equation. If you have an equation in there already, you can just hit clear. So I'm going to type in our equation, 3x squared plus 12x, and then plus 2. And then I'm going to zoom 6 this. If you press zoom and select option 6, you're telling your calculator to graph it in a standard window, which is negative 10 to 10 on the x-axis and negative 10 to 10 on the y-axis. Now, I don't need to see the vertex, but I'm lucky that it did show up. I only need to see the horizontal intercepts when I get to step 3, but I just wanted to show you that that the vertex, the lowest point of the parabola, dictates what my range is going to be. So in this case, since I have a parabola that opens up, and I'm going to try to do this in general because I know your question is different. I'm not sure exactly how the graph goes, but it does go up forever, that's for sure. The question is, what's the lowest it goes here? So what I'm really after is the y value of the vertex. I don't care what the x value is. What I want is that y value. I'm going to put a little star because that's what's important. And it would be the y value here of that lowest point. That's going to be the lowest that your graph goes. That would be the smallest y value that it takes on. So that would be the first number you put in the range. So your range in interval notation, if you have a parabola that opens up, is always going to be bracket, because that y value actually is taken on. Whatever the y value is, the vertex, comma, and then since your parabola opens up, it goes as high as you want. You're going to get all possible y values bigger than whatever that y value is there. So that would be positive infinity, and you would put a parenthesis. But just so that I don't have to make an entire video all over again from scratch, that if you had a parabola that opened down, it really is the same story. You could tell people what the range is going to be in general, and the story would just be a little different. You'd still have that magic y value of the vertex. So you find the vertex, and I don't care what the x value is. I care about the y value of the vertex. So I'm going to put an asterisk. That asterisk there, the y value of that vertex would show you how high the parabola would go. So it's a little bit different. Here my parabola is limited in how low it goes. In this case, it's limited in how high it goes. And it's not limited how low it goes. In fact, it goes down forever. So in interval notation, if you had one of these problems where your a value is negative, ours is positive, it's 3. But if you had one that's negative, say this one down here it says a is -1, you're going to have an upside down parabola, and the range would look like this. The lowest it goes is negative infinity, so put a parenthesis, comma, and then whatever the y value is of your vertex would be your highest y value, and it would take on that y value, so you'd put a bracket here. So that would be how you do the problem if the a value is negative and you had a parabola that opened down. So now it's just a matter of finding what that is. So the easy way to do this, I think, is just to, because the numbers are so simple, is to use the formula negative b over 2a to find the x value of the vertex. So our case, in general, parabola is ax squared plus bx plus c. So in our case, a is 3 and b is 12. I am to take the opposite of b, so that would be the opposite of 12, divide by whatever 2 times a is. In our case, a was 3. So this comes out to be negative 12 over 6. Rewrite that. Negative 12, 2 times 3 is 6. Negative 12 over 6 is negative 2. So all that to find out that the x value here is negative 2. That does not change my range. What I want to know is what the output is for that number. What is the y value? So the negative 2 is not what goes here. I want to know how low the parabola goes. So you either now do it by hand, take your original equation and substitute wherever you see an x, substitute x equals negative 2 in. As you would always when you have the x value of a point and you want to find the y value, you can simply plug it in. So you could do it by hand because it's easy. You could do it on the home screen of your graphing calculator. But since I have to graph it anyway, just to show you, on the graph, if you want to plug a number in, you can hit trace, and you're allowed to plug in any x value in your window. And my window is from negative 10 to 10. So that certainly contains what I want, which is negative 2. So I hit trace, I hit negative 2, I hit enter, and I get out negative 10. So if you worked out the arithmetic here, this should come out to be negative 10. And that is the y value of the vertex, and that's what I was after. So it looks like the lowest that this graph goes is negative 10. So my range is from negative 10 to infinity. So I go over here, and I do left bracket, which is the key just to the right of the P on the keyboard. Negative 10, comma, and then again, the easy way for me to get an infinity is just to use 2 lowercase o's. Or the other way is if your instructor has the math quill feature on, you can click that and just click on the infinity and hit save, and it should work. Now I screwed it up, and notice all it did was actually it looks like all it did is put in 2 lowercase o's. I don't know what all that is. Oh, it's because what I was typing. So that seems almost more trouble than it's worth. I'm just going to use 2 lowercase o's and a right parenthesis. Again, if you want to hit preview just to see that it's reading that notation correctly, and I didn't get a syntax error or anything, so that looks good. Now, I'm almost done. I've got one more to go. I've got the horizontal intercepts, and that was actually the whole reason for graphing it, was to find the horizontal intersections. You should know, though, that to find an intersection, you need 2 equations, and I've only typed in 1. So to find the horizontal intercepts, I need to just give myself some room to write here and clear all this out. and remind you that if you're trying to find where the graph crosses the the horizontal axis, which is the x-axis, that means that you need to, so here's my, ooh, that doesn't look good. Here we have the horizontal axis, and we need to find, let me get rid of this, we need to find where the graph crosses that axis. So if you were to plot any point on such an axis, I can't tell you what the x value would be, but the y value would most decidedly be 0. So the idea is if you type in y equals 0, you're basically defining a horizontal line through 0, the line where all the y values are 0 there. So you need to type in y equals 0 as a second equation. If you don't do that, your calculator would not know what to do when you use the intersect feature. It would be, what are you looking for? The intersection of this and what? So go to your y equals, go down, don't forget to type in 0, and then I'm going to regraph it. Now on my screen you see this red line going through. Yours calculator probably does not show that because it uses black, and it's drawing a black line over a black line so you don't see it. But suffice it to say, if you go to your y equals and you typed in y equals 0, just know that it is there. Let me go back to graph. Now this is going to take me a minute. If I want to use the intersect feature, this is number 3, use the intersect feature and your graphing calculator. The intersect feature is second calc. It's option 5, so press 5. It starts out on the quadratic equation. It asks me, is this the first curve you want me to consider? You press enter to say yes. And then it pops to the second curve. You press enter to say, yeah, that's the second one. And if you wouldn't have typed in y equals 0, that would never have been a second curve. That would have been the issue. So if I press guess, I'm going to get the one on the right. If you wanted the one on the left, you'd have to trace over. It really can only find one intersection at a time. I'm going to left arrow over and type, find that one first. The issue here is sometimes because the cursor is there, students think this is the answer, but look, it just says that you're guessing. So you really need to press enter again for it to run the intersect feature, and it says that the intersection is negative 3.825, and we are to round that to 1 decimal place as needed. So that would be negative 3.8. So I'm going to write in left parenthesis negative 3.8, and it said to do this as an ordered pair, I believe. It says use the intersect feature to find the horizontal intercepts. Right here, and it says horizontal intercepts as a list of ordered pairs. So negative 3.8 comma 0, right parenthesis, that's the notation for one ordered pair. And since I'm supposed to list them, I'm going to have to put a comma and then left parenthesis and start typing out my second point, which I haven't found yet. So I'm going to have to go back to my graphing calculator, repeat the process, press second calc, option 5 for intersect, and I'm going to have to press enter to say yes, that's the first equation. Yes, y equals 0 is my second equation. Do not press enter here. It's not like your calculator is going to start smoking if you do. You're not going to break your calculator, but you're just going to get that same answer again, and you're wasting your time. This is the time that's best to just trace over. If you trace over before the third prompt, it actually pops you back to the left anyway. It's kind of annoying that you wasted your time. So when it says guess, this is the time to move your cursor over to the other one. Don't forget to press enter to actually execute the intersect feature. And to 1 decimal place, it's x equals negative 0.17. So x equals negative 0.17, since this digit here is bigger than 5. If it's 5 or bigger, you round this digit up. So I'm going to round that x value to negative 0.2. So over here, I'm going to, oh no, it deleted the whole thing. Why did it do that? Let me hit undo. I'm going to now type in negative 0.2, comma, and then of course that's a horizontal intercept, so the y value was 0 there. And I'm going to cap that off with the right parenthesis. And if you read carefully, I've done all 3 steps. At this point, you now realize why I didn't do the video for all 5 functions, as I'm probably already nearing at least 8-minute video here. That would have been a 40-minute video if I'd done that. So,